Good morning, good morning. Okay, good morning once more, colleagues, and I would like to welcome you all to the last day of the Faculty of Science and Agriculture. That is the 12th. Sorry. Okay, sorry about that. So welcoming you all to the 12th Postgraduate Research Day of the Faculty of Science and Agriculture. And I would like to believe that, those who started with the conference, we hope you've rested. We know that we've been having some long days, the first day, and also acknowledge the presence of the Director of Research, Development, and Administration at the University of Limpopo, and that is Dr. Thembinkosi Mabila. Thank you, Doctor, for gracing this occasion. Thank you. So, colleagues, we continue with the same theme, which is advancing science through research, omics, uniting research, and ethics. I think it's actually proper for me to indicate that with the third keynote lecture that we are going to listen to now, this emanated from, if you recall, as the faculty, last year we ran the faculty-wide research ethics workshop. I think we had something like 155 participants in that workshop, and we ran a short survey for people to indicate as to what is it that they would like us as the faculty to run as future workshops. And I should indicate that there was something very strong that came out of that survey. And it was basically mainly from the colleagues from the School of Mathematical and Computer Sciences. And they said, can you please get somebody who can actually give us something on ethics in technology? And we said we will see that next year. We will see what kind of workshop we will run next year based on that. So this time around, given that we've got this theme for this conference, we said to ourselves, here is an opportunity to also satisfy the wishes of the School of Mathematical and Computer Sciences. And we've got today our keynote speaker, who is from the University of the Witwatersrand, and that is Dr. Helen Robertson. So we are very much excited to have her in our midst. So before I could call her to come to the stage, I'm going to read her short bio. So, Dr. Helen Robertson trained in philosophy at the University of the Witwatersrand and at the University College London, UCL. She's currently with the School of Computer Science and Applied Mathematics at the University of the Witwatersrand, where she teaches applied ethics of data science. She has research interests in contemporary epistemology and the epistemology and ethics of artificial intelligence. Her work covers some important recent technological advancements in the areas of data science and ethical intelligence, and the ethical questions and challenges that these raise. So, Dr. Helen Robertson, we welcome you to the podium. Thank you so much. Can we please give her a round of applause? Can you please come?
Good morning, Director, professors, faculty, colleagues, postgraduates. Thank you to the University of Limpopo and the Faculty of Science and Agriculture, and to you, all of you postgraduate students, for the invitation to your research day. So, the talk is entitled At the Intersection of Current Technologies and Ethics. The title should have, in fact, involved the intersection of 3 lines. So, given the focus of this conference of yours, this postgraduate research day conference, what I want to talk about is the intersection of technology, ethics, and research. So these 3 have had, of course, many important points of intersection. If we go back into the history of ethics and technology and research as far back as we go, of course, they've had many important points of intersection. So new technologies typically give rise to new and unexpected ethical challenges. So all of you, of course, well, not all of you, but I think a number of you are studying agriculture. If we think of, you know, the developments of the technologies within agriculture to allow for sort of large-scale farming, these come with a whole range of ethical considerations, both benefits but as well as ethical challenges, the ways in which they interact with our environment, the impact that they have. So of course new technologies always come with new challenges. And then research both utilizes and produces new technologies. So if we think of the field of physics, for example, if we think of research that goes on in the field of nuclear physics and the development of nuclear reactors, nuclear accelerators in the earlier parts of the 20th century, these of course then are both the products of research and research utilizes them, so they are needed for research. And of course there's this close intersection between technology and research. And so finally, of course, then within research we find that new ethical challenges arise in some of their earliest forms. So where we find these ethical challenges with technologies, it's often researchers that have to deal with these ethical challenges before anybody else, because they're using the technologies first. So if we think of the field of medicine, for example, it's got a very long history of informed consent and the development of drug trials. This is where we find these sorts of ethical challenges addressed in their very earliest forms. Okay, so of course we have intersection of ethics, technology, and research going very far back. So what I want to do today in this brief talk is to try to make clear how what's going on at what we might call the non-evaluative or factual level. So when we look at what's going on as a matter of fact in research and technologies, how this can interact in subtle ways with what's going on at the ethical level. So I want to draw this out by means of just 2 examples that I'll put forward. And then towards the end, I'll discuss the various ways in which ethical challenges are addressed, some of the kinds of solutions that we find to ethical challenges faced at this intersection. Okay, so I'll begin with, so just to note once again what we're interested in is, of course, the intersection of new technologies and ethics, new technologies and research, and of ethics and research. So what I want to begin by doing is putting forward 2 examples of current technologies within research projects. All right, so I'm not going to refer to any specific research projects. I understand that all of you have got a lot of research projects underway. I saw your program and I see that there are many, many abstracts in there. So I'm not going to refer to any sort of specific research projects, but these examples are illustrative of a range of cases, of the sort of research that's going on at the moment. So they won't be, I think, unfamiliar, this sort of research, nor will the risks and potential benefits of this sort of research be unfamiliar either. But what I'm hoping to do, as I mentioned, I'm hoping to sort of make clear some of the intricacies that go on, some of the more subtle ways that what goes on at the factual level in terms of research, the factual level of technologies and research, how this can interact in perhaps unexpected, subtle and systematic ways with what goes on at the ethical level. All right, so to begin then with just a couple of sort of briefly described examples. So at present, of course, we find many research projects that aim to exploit the increasing amount of health and medical data. All right, so first there is the collating of large and heterogeneous data sets. And then secondly, computational techniques are used, which I'm sure will not be unfamiliar to many of you. Often so-called machine learning techniques are used. So for example, we might have a project that obtains, for example, large-scale statistical data, numbers of instances of various diseases within some geographical area, say the treatment, success of treatment, and so on. So we've got large-scale statistical data. They might also obtain information on individual patients. So we might have, for example, X-ray and other images, details of their physical and medical histories that extend, in fact, beyond a given patient to the history of disease or other medical conditions in their families. We might have genomic data, and it's also possible to obtain, of course, clinical records in the form of doctors' handwritten notes that are used ordinarily in day-to-day hospital activities. Okay, so a whole range of data that is available to a project like that. And previously, of course, although all of this data sort of overlaps in subject matter, so although it's all data about what's going on within these patients within this geographical area in terms of their medical conditions, if we're thinking in terms of previous techniques, previous technologies for working with data to collate or combine this data into a single data set or a number of usable data sets would have been virtually impossible. Some of this would have been done by hand if we have doctors' handwritten notes and so on. But of course now, given a range of computational techniques, it's possible to take a range of very different kinds of data, unstructured data, and to collate it into a single data set or a number of data sets that are then usable. All right, so we find, of course, that we then have these large, rich data sets that can be used. And then the second part, in the case of such projects, is to develop models and other, for example, end products like dashboards that doctors might use, doctors within various areas from the urban to the rural, that they might use, that might be useful to them in treating patients. Right? So in the case of the development of these sorts of end products and other models, often what we find is that models are developed, again, using machine learning techniques. So for example, we might have a model that's developed in order to predict for a certain genetic disease, and a doctor in an urban or a rural setting might then be able to use a dashboard in order to manipulate data, in order to find out further information about causes and such in order to treat patients. Okay. All right, so that's one sort of example of the sort of research that we have going on at the moment within the health sciences, within biomedicine. And of course, this makes research, this makes use of technologies that allow for these large, multidimensional data sets and technologies that allow us to work with these large, multidimensional data sets. All right, as a second example, we might consider research into town planning and infrastructure. So we can consider, for example, a project that aims to model changes and growth in housing and infrastructure within, say, some specified geographical location. Again, in contrast to the research of a few decades ago, again, it would be possible to use a wide range of data sources for this. So we might have municipal data, we might have survey data, satellite data, that's using images taken from satellite in order to work out the different areas of housing and where we find dense versus less dense areas and so on. We might be using telecommunications data. And so similarly, we might find that we would have large, rich data sets for a project like that. And we now have the technologies and the tools to work with these large, rich data sets. So it could be that there is the development of a model on the basis of now all of this rich information that predicts for example, the allocation of resources across different geographical areas on the basis of this rich information, as we've said. Okay, so 2 examples of the sorts of research projects, very big research projects sometimes, that have a lot of funding put into them, that we find at present that make use of sort of the most advanced technologies in terms of the creation of data sets, as well as working with these data sets and extracting information from them. All right, so far we've only looked at the intersection of research and current technologies, right? So we've only looked at these 2 and how they currently intersect. And so to turn to the ethical consideration of these, suppose we're thinking of the first case, the case in which we have machine learning models that are developed using large multidimensional data sets in order to predict for some genetic disease. All right. So in this case, it's clear that there are weighty ethical considerations or reasons both to be in favor of this sort of research that uses this sort of technology, but also to be cautious about it. So to give some examples that might very well come to mind, I don't think that this is unfamiliar. So one consideration or reason for being cautious is, of course, that individuals have a right to privacy over medical information, right? And this, of course, has a long history. Medical information is thought to be particularly sensitive information, but in general, this right to privacy over one's data, over one's information is recognized. And so this is then, of course, an ethical reason to be cautious about the use of these technologies and how we use them. Similarly, there might be further harms that can result. So medical information being particularly sensitive information, we might find that, if this information is obtained by further organizations, further individuals, there is the risk of further harm. It might be used in a more systematic way by health insurance companies, for example, or it might have sort of other unforeseen harms associated with it. So again, another reason for us to be cautious about the use of these technologies, an ethical reason for us to be cautious about the use of these technologies. But of course, on the other hand, as we know, there are good and strong ethical reasons for us to think that these technologies are worthwhile, that we ought to be engaging in the sort of research, that we ought to be developing these sorts of technologies. So as we know, particularly now that we have these large, rich, extensive data sets to use, and we've got the technologies to be able to extract information from them, we know that the research can result in significant benefits both to society and individuals, and particularly to those at the sort of lower levels of society, the more impoverished, less privileged levels of society. Okay, and so, of course, this is then again an ethical reason, but an ethical reason for us to be in favor of the use and development of these technologies. Right. Just one further consideration, which I'm going to focus on. More recently, a further ethical consideration or reason for us to be cautious has become clear or become apparent, and that's that in computational terms is to get average accuracy across the entire data set for whatever you're predicting for, right? And it turns out that this average accuracy across the entire data set then has the consequence of far less accuracy in the case of certain subgroups. Right? And this is for various reasons, depending on what's in the data, depending on which computational techniques are used. But it's turned out that, in fact, there is this decreased accuracy across important subgroups. All right, so this is a consideration. This isn't an ethical consideration that, you know, we could have predicted before the use of these technologies. It's become apparent since these technologies have been used. And so what I want to do is just look in a little bit more detail at how, so this is a fact about the use of these technologies, namely that in some cases we have that predictions are significantly less accurate for some subgroups in comparison with some other subgroups, all right? And so what I want to look at is how this matter of fact about these models then interacts with what goes on at the ethical level. And it can interact in sometimes some unexpected and subtle ways. All right, so typically what we have, as mentioned at the non-evaluative level, is this prediction where we have significantly less rather than some other subgroups. And in cases, supposing that we're thinking of our previous case of our project within health sciences, within biomedicine, where it goes either along ethnic or racial lines, given how our societies are divided up economically, given various sort of factual and contextual details about our societies. This has typically been either along racial lines or, depending on the case, along gender lines.